Hi! If you want to develop great games, you have to understand maths and physics. And both in maths and physics, you will have to use trigonometry. And this is an opportunity for you to do some practice. So let's start with something really simple. This is a right triangle. It has a right angle here. This angle will be alpha. Let's put some letters A here, B here, C here, and just trigonometry primer. Sine alpha is A divided by C. Cosine alpha is B divided by C. And tangent alpha is A divided by B. But now, what if the task we have is to find sine alpha, but we only have the values of A and B, and not C. The main formula for sine alpha is A divided by C. We know A, we don't know C. But here, Pythagoras can come with help. So, from this triangle we get C square equals B square plus A square. Okay, so C is a square root of B square plus A square, and so our sine alpha becomes simply A divided by square root of B square plus A square. Let's take another example. A very similar triangle which has alpha here, right angle here, A here, B here, C here, but this time we know sine alpha and we know A. Okay, and we need to find what is B and what is C. The general rule is we should start with something that we know. If we know sine alpha, then let's try to use the formula for sine alpha, which is A divided by C. And here it is quite easy to notice that there is a sine alpha here, which we know, there is A, which we know, and there is C, which we are looking for. So, multiplying both sides by C, I will get C sine alpha equals A. And so, now dividing both sides by sine alpha, I get the formula for C. C is A divided by sine alpha. So we have found the first of the edges that we are looking for. The second one is B, but now looking at this triangle, I can notice that I know the value of A and I know the value of C. I am only looking for B. And again, equals A square plus B square. This is Pythagorean theorem, and B from this formula, B square is C square minus A square, so B is square root of C square minus A square. A square we have here, and C we have just calculated. That's it. Let's now proceed to something a little bit more tricky. We have a very similar triangle once again. Alpha is here, right angle, A, B, C, but this time we will, again we know sine alpha, but apart from that we will know the value of B. And what we are looking for is A and C. What's the problem with this? If we repeat the same approach as last time, so we will try to write the formula for sine alpha. Sine alpha is A divided by C. We know sine alpha, but wait a moment, we don't know A and we don't know C. They are both unknown values that we are looking for. But In trigonometry, if you have a trigonometrical function of one type, you can easily get trigonometrical function of another type. If we look at this triangle, we can easily find out that, for example, if we might have cosine alpha. Cosine alpha is b divided by c. In this case, c, which we are looking for, is relatively simple to find. It's b divided by cosine alpha. Okay? So how can we find cosine alpha if we only know sine alpha? From a equation which is known as trigonometrical unit. This equation says sine square alpha plus cosine square alpha equals 1. We are looking for this part. So cosine square alpha equals 1 minus sine square alpha. So cosine alpha is the square root of 1 minus sine alpha, of course, sine square alpha. Here it is. Now, substituting this result to this formula here, we get c equals b divided by square root of 1 minus sine square alpha. And this is our result. I will not present how to find a, because it's the same method as last time. We would just apply Pythagorean equation. Now let's proceed to something like a hardcore trigonometrical problem. We have a triangle like this one. Please note that none of these angles is here marked as right angle. So this is not a right triangle. We cannot directly find sine alpha or sine beta. We cannot directly use Pythagoras to this triangle. What we usually do is we try to find the right triangle somewhere here. I will add a new line here, which actually is the height of this triangle. Okay, but now I have two right angles here, and in principle I have two right triangles now. Once I've done it, I can actually go further with this example. But let's have a look at what we actually know about this triangle and what we are looking for. We know that the B, this edge, is 10. We also know sine of this angle and sine of this angle. And what we are looking for this edge here, which is called here A. Let's start from something we know. So sine alpha, it's now clearly visible that this is h divided by b. Okay, and we are working with this right triangle here. So it is h divided by b. And from here we have the first calculation. H is multiplying both sides by b, b sine alpha. But we also know that b is 10 and sine alpha is 0.8. 10 times 0.8, it is 8. Okay, so we know slightly more about this triangle because now we know the length of this and the length of this. Another piece of information we have is sine beta. So let's have a try with this. Sine beta, it is from this h divided. I need to add a new symbol here. I will call this thing here C. So from this triangle, sine beta is h divided by c. H divided by c. So again, h is c sine, attention, beta, not alpha. Okay, it's not very useful for me because I've already calculated h, but from this formula I can find c. So c is h divided by sine beta. And substituting the real numbers h from this calculation, I know it is 8. Sine beta, I know it's 0.5. So it's 8 divided by half. Division by half is the same thing as multiplying by 2. So it's actually 8 times 2. It is 16. Now, looking at this triangle, I could say that this part here will be called x, and this part here will be called y. From the first triangle, using Pythagoras, I get b square equals x square plus h square. Okay? From this I can easily find x square, which is b square minus h square. And now substituting real numbers, b square is 10 square minus h is 8. So it is 100 minus 64. It is 36. So my x equals a square root of 36. It's easy, it's 6. For the second triangle, we get c square equals h square plus y square. And we are looking for y, so y square is b square plus, minus, wrong. I was looking at this formula. Y square is of course c square minus h square. C is 16. 16 square is 256 minus h square is 64. So it is 192. So that y is a square root of 192. 192 is the same thing as 3 times 64. We actually don't have to do it, but it is just to allow to present the result in a slightly nicer way. So I will write here 3 times 64. 64, the square root of 64 is 8, so the result is 8 times square root of 3, sorry. And now the final result, A, is of course x plus y. This is the reason why we wanted to calculate x and y, and this is 6 plus 8 times square root of 3. This is the final result. I have for you one more final example. This right here we have here two triangles with a right angle here. We know sine alpha, sine of this angle here. We also know C, this edge of this triangle here, and A. So we know a lot about this strange triangle here, which is definitely not a right triangle, and we are looking for beta. If we are looking for beta, this actually means that whatever we found, whether it is sine beta or cosine beta or tangent beta, will be equally good. Alright, so let's start with what we can find from sine alpha. Sine alpha equals, okay, this edge divided by this edge C. So we need to introduce a new symbol here. I will call it H because this is actually also the height of these triangles here. So sine alpha is H divided by C. H divided by C. From this we can very easily find that H is equal C sine alpha, and looking at the data we have here, which look pretty much similar to the previous example, C is 10, sine alpha is 0.8, 10 times 0.8 is 8, so the height again is 8. Now, once we know this height here, and we know C as well, we can use the Pythagoras equation of Pythagoras to calculate the entire length of this basis here. I will add one more symbol, B, for this section here, from here to here, okay? And so what I get is A plus B square plus H square equals C square. In this equation we know C, we know H because we have calculated this, and we also know A, so we should be able to easily calculate B. A plus B square equals C square minus H square. C square is 10 square, it's 100, minus H square, it's minus 64, this is 36. So A plus B equals square root of 36, which is 6. Now we are looking for B. B apparently is 6 minus A. A is 2, so B is equal to 4. We are looking for the angle of beta, and we already know B, which is 4, and we also know this H, which is 8. Knowing B and H, we can actually very easily find the value of tangent beta, because tangent beta is H divided by B, which is 8 divided by 4, which is 2. And this is the final result. Thank you very much, and watch also my video about binary subtraction. Thank you.